Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of predictions from simple experiments. This is standard 7.6H in the great state of Texas, and we are using item number 1 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So Mari bought 6 packets of tomato seeds, and each packet contains 24 seeds. So you know what, we can easily draw a picture of that, because sometimes rather than an expression or an inequality, a good old picture might help us solve a problem. So I'm going to draw 6 packets of 24 tomato seeds. So she planted 1 packet of seeds and 15 seeds sprouted. So half of 24 is going to be 12. 15 is a little bit bigger than that, so I'm going to kind of just draw a line a little bit more than halfway. Kind of do a little bit of light shading right there to say that a little bit more than half of her 24 seeds actually sprouted. So we need to find a statement about the seeds in the remaining packets. All right, so the remaining packets, these 5 right here, these unopened, we already know about that first one, is best supported by this information. And take a look, it looks like we've got a range here, so no more than 50. So I'm going to kind of put this on a number line here to help us visualize this. So we've got 0, and it looks like we've got 120, right? So D is all 120 are going to sprout. So I'm going to say 60 is in about middle, so 50 is going to be right around here. So no more than 50, this is what A is asking for, is anywhere right between 0 and 50. We've got about 50 and 100. It's going to be my B. And then we've got C, which is between 100 and 120, and then D is all 120. So it's kind of interesting. We just need to find the number and see where it lands on this number line. Well, there's a few different ways we can do this. There's at least 3 that I can think of, and you might be able to think of a different one. But look what I already did on this first one. I already just kind of shaded in that first one, and so I could just kind of continue that. And so visually, I can just see, well, 15 and 15, and then basically 5 15s. So I could do a little bit of repeated addition if I want to. I could do 5 15s. Some of you might be thinking that's way too hard. Let's just multiply 5 sets of 15. That would also work. We could also make a proportion here. So let's look. I've got 1 packet, and I've got 15 sprouts. S will be sprouts. So I've got how many remaining packets? I've got 5 remaining packets. So I need to know how much will sprout. That's what we're looking for. How many sprouts are in the remaining packets? So S is my unknown, but take a look at what I'm cross multiplying here. So 1S, so basically S equals 15 times 5. All right. There's also a really kind of long way to do it. I could say instead of 15 over 1 or 1 over 15, I could say 15 sprouted over 24 total, because there were 24 total seeds in that packet. And so now I would be looking for how many sprouted, but then I got to figure out how many total there are in the 5 remaining packets. So that's going to be 24 divided by 5. Okay, so that's going to be, that's where that 120 comes in. Okay, so 120. But now look what I got to do. Eesh. 15 times 120 equals 24S. So then you got to multiply those two, divide by 24. Too much work. Let's just do this. 15 times 5, you've already figured it out. My answer is 75, which means it lands right here on B.